Hey everyone, I'm Travis Spivey, joined with my son,
Jordan Spivey, and if you're new to the channel, hit that subscribe button so you don't miss out on any of our awesome science videos. Also, scan the QR code at the top left of the corner of the screen to contact us and explore more of our awesome content and material.
In today's video, we will discuss static electricity through conduction, induction, and friction. So let's do this.
Our learning target for today is, I can describe and explain how static electricity occurs through conduction, induction, and friction. Let's first answer the question, how does charge build up? Most objects have no overall charge. An atom usually has many electrons as it has protons. This leaves the atom uncharged or neutral. An uncharged object can become charged by gaining or losing electrons. If an object loses electrons, it is left with more protons, giving it an overall positive charge. If an object gains electrons, it will have an overall negative charge. The buildup of charges on an object is called static electricity. In static electricity, charges build up on an object, but they do not flow continuously. Static electricity follows the law of conservation of charge, which states that charges are neither created nor destroyed. An object cannot become charged by destroying or creating its own electrons. If an object loses electrons, another object must pick them up.
There are four methods by which charges can redistribute themselves to build up static electricity: by friction, by conduction, by induction, and by polarization. In this video, we'll cover the first three. So let's start off with conduction first. Charging by conduction is the transfer of electrons from one object to another object by direct contact. Conduction occurs on a neutral object when a charged object is in contact with it. During conduction, the same charge is created in a neutral object. Electrons will transfer from a negative object to a neutral object, making it negative. Take a look at the following diagram. The glass rod is negatively charged. The balloon has no charge. When the glass rod makes contact with the balloon, some of the negative charge is transferred from the rod to the balloon. The balloon now has a negative charge from static electricity as a result of direct contact from conduction. Also, have you ever been electrically shocked when you touch something or someone? Is the temperature usually cold or warm when this happens? I'm pretty sure you have been shocked before, but let's talk about why this static shock occurs. Cold air holds less moisture than warm air, so there is a lower humidity level and less water vapor in the air in colder temperatures. With less water vapor in the air to conduct this charge away from you, your body can carry a higher static charge. With a higher static charge, there is a greater static discharge or release, which causes static electricity to move from you to another person or object and vice versa. Quick check for understanding. In what type of temperature do most people experience static shock? Explain why.
Let's take a look at charging by induction. Electrons can react to the electric field of a charged object without touching the object itself. In some materials, like metals, electrons can easily leave their atoms. When a metal object is close to a negatively charged object, electrons are repelled by the field and move away from it. The close end of the metal object becomes positively charged and the far end becomes negatively charged. This process is called induction. Take a look at the following example. In the first diagram, A and B balloons are overall neutrally charged, meaning that they have the same number of protons and electrons in each balloon. But look at what happens when a positively charged glass rod is brought near balloon A. The negative charges come closer to the glass rod and the positive charges move away from the glass rod. Notice that the glass rod did not touch the balloon, but used the attraction of charges to bring opposite charges closer together and repel the like charges. Now on diagram D, balloon A has a negative charge and balloon B has a positive charge. Quick check for understanding. What made balloon A have a negative charge and what made balloon B have a positive charge?
Now let's talk about static friction. Friction is the transfer of electrons from one uncharged object to another by rubbing the two objects together. Some electrons can move from one object to the next when you rub them together. Take a look at the following example with rubbing a balloon on your hair. Rubbing the balloon against your hair causes the electrons to move from your hair to the balloon. Because electrons are negatively charged, the balloon gets a negative charge. Since your hair lost electron negative charges, it now has an overall positive charge. Quick check for understanding. What makes the balloon attracted to your hair now?
In summary, static electricity can be caused by conduction, induction, and friction. In static conduction, a neutral object is touched by a charged object, which now makes the neutral object gain a charge. In static induction, a charged object is brought near another object, which causes the opposite charges in both substances to come close to each other and the like charges move away from each other. Notice that in conduction, the object is touched, but with induction, the objects are just close to each other but never touch. In static friction, electrons are transferred from one uncharged object to another by rubbing the two objects together. Just like rubbing a balloon on your hair or rubbing a comb on your hair. Both examples cause a charge due to the rubbing of two objects together.
And that's our video for today. Now let's test your knowledge to see how proficient you are with describing and explaining how static electricity occurs through conduction, induction, and friction by taking our video quiz.
Use your electronic device to scan the QR code at the top right of the screen, or you can click the link in the description box below the video to take the quiz.
Remember, 80% or higher for proficiency. Record your results on your proficiency sheet, and if you don't get it the first time, you better keep going because it's not over until you win.
Don't forget to hit that subscribe button, click that bell icon, and also scan the QR code to contact us and explore more of our awesome content and material.
Peace and have a positive, productive day.
Where is your spear? Our foremothers gave us this spear because it is precise, elegant, and deadly.